So this is the SN1, SN2 experiment. We are going to test 6 different alkyl halides and test their reactivity in both SN1 conditions and SN2 conditions and see the relative rates of each alkyl halide. We're first going to start by testing each of our alkyl halides in SN2 conditions. So that's going to be our sodium iodide and acetone. And you see I've got 6 test tubes here labeled 1 through 6. And I've got my alkyl halides labeled out for you 1 through 6. So I start with the chlorine derivatives and then I move on to the bromine derivatives. And I go from primary to tertiary. So we're first starting just by adding a few drops of each alkyl halide to the respective test tube. We're then going to add a pre-made solution of sodium iodide and acetone, and we add 2 milliliters to each test tube and just gently shake them. So it looks like we do have a reaction after even just, a minute with test tube 4, which contained our 1-bromobutane. But it looks like the rest of our test tubes really don't have any reaction. So we're going to heat these guys to 50 degrees Celsius and see if we can't get a reaction to form, a reaction to occur. Think about in test tube 4, we see this cloudy mixture. We even see some precipitate coming out of solution. So if I hold this up against this black background, we see we've got that solid forming in the bottom. What is that solid that's being formed? This solid that forms, right, we're looking for a precipitate, and it really is an indication that the reaction worked. So think about what that could be. In the meantime, we'll heat the rest of these and see if we can get solid to form in the other test tubes as well. So we're going to heat this guy, not to 250, we kind of overshoot it so we can get this hot, but we're going to heat these test tubes to 50 degrees Celsius. Why specifically did we choose 50? Think about the solvent that is being used to react with our reagents. So we're going to heat the rest of these test tubes in a water bath to 50 degrees Celsius. Think about why specifically we're going to heat to 50 and not beyond that temperature. And you can think about the solvent that's being used in these reactions to encourage that SN2 type reaction. So we're going to do the same type of reactions, but we're going to instead take each of our alkyl halides and we're going to react them with sodium nitrate and ethanol. And these are the conditions that promote an SN1 type substitution. So you see again, I have the same key here, 1 through 6, and we start with our chlorine derivatives and then we move on to our bromine derivatives. And again, I'll just add 4 drops of our alkyl halides to our test tubes, and I will then add 2 milliliters of our sodium nitrate and ethanol mixture that is already prepared for us. So this is the reaction with our alkyl halides in the silver nitrate and ethanol conditions, or SN1 conditions. And pretty instantaneously we saw number, I believe 3, 5, and 6, and number 4 is taking a little bit of more time, but those are pretty instantaneous when we've reacted that. And so 3, we've got our tertiary alkyl chloride, and then we have our secondary alkyl bromide and a tertiary alkyl bromide. So it seems like those react pretty fast. And like I said, 4 took a little bit more time over here. It was our primary bromobutane, or 1-bromobutane. And that one's a little bit interesting, huh? It typically wouldn't form a carbocation, so maybe it goes through a different pathway to react. But you see, it's definitely reacted. Maybe not as good as the others, but we definitely see some cloudiness and precipitate forming. This is number 3. This is our tertiary alkyl halide. Definitely a lot of precipitate in there. As we go along, think about what that precipitate could be. And remember, that is our indication that the reaction has formed, or a reaction has worked. See a lot of precipitate down at the bottom there on our tertiary bromide. But it looks like number 1 and 2, so these are our primary and secondary alkyl chlorides. We see that there's nothing in there, so we're going to heat these to 80 degrees. Again, think about why we specifically chose 80 as our heating temperature, and we'll see if we can't get these reactions to go. So these were our alkyl halides in the SN2 conditions, so it's that sodium iodide and acetone. And these were the ones that didn't seem to work initially at room temperature. So we're going to check them now. They've been reacting at 50, actually they got a little bit higher at 60 degrees Celsius. But we're going to check them and see how they've changed over time. So this is number 6. This is our alkyl, our tertiary bromide. And we do see, try and get a better view here. We do see a little bit of solid forming at the bottom. Put it over here. So that white solid there. And it's just a little bit, and we also see that our reactions just kind of turn yellow. But we see it there. So there's a little bit of solid there. Number 5 is our secondary alkyl bromide. So you see we actually do have quite a bit of solid in there. Maybe not as much as our initial primary bromide, but pretty decent amount of solid at the bottom there. Remember, number 4 was the one that worked at room temperature, so we're going to move on to number 3. And we still don't see a reaction as indicated by no precipitate. That was our tertiary alkyl chloride. Move on to number 2. This is our secondary alkyl chloride. Again, we don't see any precipitate in that vial, or that test tube. And then number 1 was our primary alkyl chloride, and don't really see too much in there. It's a little bit cloudy, but no distinct solid coming out of solution. So this is number 1. All right, so now we're going to do some tests with our solvents to see how increasing the polarity of our solvent affects the rate of our reaction. So we're going to just do 3 main tests with different concentrations of water with propanol. And so that's going to be our solvent, and we're only going to test this specific tertiary alkyl bromide because this alkyl bromide favors reacting in our SN1 conditions. So we'll see how increasing the polarity of the solvent affects the rate of this substitution reaction. In your table, it says 50, 40, 60, but I'm going to start with the highest concentration of water. So it's 40% propanol and 60% water. And I'll increase the polarity it'll be decreasing the polarity as I go along. Our water is the more polar solvent. The propanol is the less polar solvent. I'm going to add 5 milliliters of our solvent.
If you look at my glass, you can see it there.
We're going to add 0.1 milliliters of our base, our sodium hydroxide. And we'll add 1 drop of our phenolphthalein indicator. Okay, so we've got our pink solution here. And the last step is to add 2 drops of our alkyl halide. And we'll start our timer. So I've added my sodium hydroxide and my phenolphthalein, so I've got my pink solution, and now I'm going to add my 2 drops, and this is the 50% propanol and water. And I'll start my timer. This is our 60% propanol and water with our tertiary alkyl bromide. All right, so now that we've tested our tertiary alkyl bromide, we're now going to test the same 3 solvents. So our 40% propanol and water, our 50 and our 60%, and I have those set up here. I've already got the sodium hydroxide and the phenolphthalein, and you can tell that because we now have our pink solutions, but we're going to be testing our 2-chloro-2-methylpropane instead. And what I'm gonna do is have a time lapse set up for you guys. And I'm going to add the alkyl halide, our 2-chloro-2-methylpropane, to our test tubes all at the same time, so you can kind of see the relative rates of those 3.